Today we'll be starting present value annuity. Now the formulas for future value annuity, that is ordinary annuity or annuity due, both the formulas will remain the same. Now today we'll be beginning with question number 17, where you have the question where you have to solve both payments made at the end of the year and payments made at the beginning of the year. Let's look at the question. Mr. Tony Stark is evaluating two annuity investment schemes offered by Indian Bank. Two options include ordinary annuity and annuity due for the duration of 3 years, which involves rupees 5,000 at an interest rate of 7%. So he is asking us to find out what would be the present value of the future cash inflows of rupees 5,000 for a continuous 3 years. So here we'll be solving present value annuity even cash flows. That means same amount of money you'll be receiving every single year. So here I've put up a table format for easy understanding. We'll do after which formula format also, but let's do it in a table format first. So here I'm going to start ordinary annuity, that is payments made at the end of the time period. Remember, payments made at the end of time period, your interest is going to not be accounted. Only for the first 2 years you'll be getting interest. So let's start 1, 2 and 3 years. Annuity will remain the same, 5,000, 5,000 and 5,000 each. Interest is, remember, while writing interest in the table format, please don't do this mistake by just writing 7% or just by writing 0.07. Here I mentioned in the formula 1 plus the interest rate to the power of n. N is here the number of years. So you're going to do 1 plus 0.07 to the power of 1, to the power of 2 and to the power of 3. So to the power of 1, it's going to be 1.07, and then to the power of 2, it's going to be 1.1449. Third year, I will not be getting interest because it's payments made at the end. So it's going to be nil. So 5,000. So what's your fourth column? Fourth column equals to your second column divided by your third column. So last class we studied, right? Present value means you need to learn to start dividing the values. If it's future value, you have to multiply the values. So here present value of cash inflows are 5,000 multiplied by 1.07. That is 4,367. 5,000 into 1.14449 is 4,673, and the last one will carry forward as it is 5,000. So when you're totaling the amount, it will amount to 14,040 rupees. So let's solve the second part where the payments are made at the beginning of each time period, which is called as annuity due. Again, you have the same columns here: annuity, interest rate and present value of cash flows. So here is 1, 2 and 3. Annuity is 5,000 a year. Interest is 1.07 for to the power of 1, then 1.1449, and then we have 1.2250. So here when we are multiplying 5,000 divided by 1.07, we get the same value, 4,367. Second, 5,000 divided by 1.449 is 4,637. 4,673 rupees. And the last year, here I'm going to be charging interest because the payments are made at the beginning of each time period. So the last one is 5,000 into 1.2250 is 4082. which amounts to 13,132 rupees. So in the table format, when we are solving, if payments are made at the end of time period, my amount is 14,040 rupees. If payments are made at the beginning of time period, my answer is 13,122 rupees. So let's look at the first way of that we would solve is the formula method. Now here I put for both, that is payments made at the end of time period and payments made at the beginning of time period. Now the same thing formula, present value of annuity equals to A divided by 1 plus I to the power of 3 minus 1, A divided annuity divided by 1 plus I to the power of 3 minus 2 and plus A. As I told, if payments are made at the end, there's not going to be any interest payment. So I implement the formula 5k divided by 1 plus 0.07 to the power of respective rate of power. And then when I simplify that, I get the same answer, 4,367, 4,673 and the last is 5,000. Add up all together, I arrive at the answer 14,040 rupees is my payment under annuity, that is the payments made at the end of time period, ordinary annuity. The second part is annuity due, where the payments are made at the beginning of time period. The formula is A divided by 1 plus I to the power of 1, A divided by 1 plus I to the power of 2 and A divided by 1 plus I to the power of 3. I put up the respective values and to the power of the formula, I end up with the answer 4,673 for the first year, 4,367 for the second year and 4,082 for the third year. So when I'm going to add up or sum up the entire values, I arrive at the answer 13,122. So if you can observe, the answers haven't changed here, only the method of calculating the amount has changed. So either if you're doing a formula ways, you will end up with the same answer, or the original wise, if you're going to do table format, it's still the same answer. So this completes question number 17. So let's move to the next question, question number 18. So the given criteria here is find out the present value of rupees 9,000 received at the end of each year for 5 years if it is discounted at 10%. Now here the question is not mentioning whether the payments are made at the beginning or at the end. So question is silent about that aspect. So what you need to do is, once you find such questions, once you're beginning the solution for such question, either you can put up the heading as ordinary annuity, payments made at the end. You can just give it at a heading, or you can give a heading annuity due, payments made at the beginning of time period. So whatever the heading you can put, and then accordingly you can solve, because the question is not stating whether the payments are made at the end or beginning. So here if we can look at ordinary annuity, in the table format I have solved it. 5 years, 9,000, because it is even cash flow. 9,000 is the same amount you will be receiving every single year. The present value cash flows, how is it calculated? Your second column divided by your third column. So it's going to be 8,182, 7,438, 6,762, 6,148 and the last one is 9,000. The reason it's 9,000 is because payments are made at the end. Therefore, no interest will be charged in the last year. So your total will come up to 37,530 rupees if payments are made at the end. Second type, annuity due if payments are made at the beginning. Again, 4 columns, year, annuity, interest rate and present value of annuity. So again, to find out the last answer, the last column, annuity divided by your interest rate. So you'll get the values from the first to fourth year. The values are going to remain the same. Only the last year value is going to change because here we didn't get interest. Here we will be charging interest at the rate 1.610. So 9,000 divided by 1.610, your answer is going to be 5,590. So once I'm going to total it up, I'll get an answer of 34,120 rupees. So under the table format, it is payments made at the end 37,530, payments made at the beginning 34,120. Remember, the question is not mentioning to you whether you have to solve ordinary annuity or whether you have to solve annuity due. So the option is yours. Either you can solve it in this method or in this method. Just to make sure that you put up a heading under which method are you solving. Payments are made at the beginning, payments made at the end.